Hello, everyone. We're live. Kyle, AA0Z, with a Nat in my shack, and we're here with Smitty.
Hi,
Hello, how are you?
I am well. I am
What?
N6MTS.
Yeah, sorry. There's gnats in this room. Oh my
I keep
gosh.
telling him to get out the chopsticks, but it hasn't worked for him yet.
So we're here with Smitty, and Smitty and I met for the first time at Hamvention this past year, a month and a half ago, and he is doing some really cool stuff. You know Smitty from the Ham Radio Workbench. Everyone knows Ham Radio Workbench. It's the great podcast that you can mow your lawn with. Or two, you could take your kids to school 4 times a week and still be on episode 1. It is, if you're not subscribed to Ham Radio Workbench, you should. So go and subscribe to that. But then Smitty is a participant on that podcast, and he is doing some really cool electronic things that I want to get into and talk to him about what he's doing in the world of ham radio and electronics. Because being a old ham in this hobby, I've got like some renewed energy about all of the cool things you can do with circuit boards and this new PCB process of literally, like, you can design something on your computer, send it off to a PCB maker, and a couple of days have something working.
Usually a couple of weeks, but yes.
Yeah, but it's not like not like months, right?
No, it's a quick turnaround. Yeah.
Yeah, and same with 3D printing. 3D printing has revolutionized some of these cool things that we can do. So, first, hello everyone to the chat. If you got a question for Smitty, please ask it in the chat, and we'll bring it up and have him talk about it. But first, I know that it's very hard, but we're going to try to keep this to an hour. But let's give. What is your background? How did you get into ham radio, and how did you get into electronics? And give us a little rendition of your history here.
Yeah, sure. So I grew up in Silicon Valley in the 80s and 90s. My mom was a network engineer at a local high school. My dad worked for IBM for 32 years. So I was doomed to be a nerd from day one. I'm like, I didn't have much of a choice in the matter.
Yeah.
Having said that, I am quite happy with the way I am, the nerdery that I do.
the nerdery.
But I got into computers when I was very young. I had 2 older sisters, and our first computer in the house was a TRS-80 Model 1 when I was 3 years old. My sister bought it with her saved up babysitting money.
Yeah.
And so, like, I learned how to program BASIC on that thing. And then my dad worked for IBM, so we got PCs at home, and I grew up building and upgrading PC architecture, DOS, then Windows. Then I got into college in 1993, and I found Linux.
Yep.
And I was one of the very early adopters of Linux. My first kernel compile was version 0.99 patch level 13G. It took 36 hours.
So what did you compile that on?
It was a 386 SX with 4 megs of RAM.
Yeah. Was it like an AST or something?
No, it was a home built machine.
Oh, it was a home. Okay, gotcha.
Yeah, I mean, home built. I don't remember the brand of the motherboard, but it was, a discrete motherboard, a discrete CPU, discrete RAM. It wasn't a prepackaged machine.
Gotcha.
I don't think that I've ever bought a prepackaged machine. I think the last one my family ever bought was that XT286 that my dad brought home from work. It was a PC Junior, then the XT286, and then everything after that we started building on our own.
Yeah.
I mean, welcome to the Silicon Valley, right? I grew up at just a few miles from a little tiny hole-in-the-wall shop in downtown Mountain View on the corner of Castro and Dana that was called Data Tech. And it was just this Chinese guy who had family back home that would ship him products. And so he was his own little importer of all of these, not knockoff, the other brands, not the IBM brand, but, and so he could get any of these parts that we wanted, and they were really good prices. And we just started building our own machines for a lot cheaper than you can get anywhere else.
Yeah, my first computer that I built right before I went to college, you and I are we're the same age.
Yeah. Okay.
So mine was an AST, and it had the math coprocessor because I needed that for Mathematica.
Oh yeah. Yep. Yep.
And
Floating point.
yep. And I had that in my dorm room and used that and discovered bulletin boards, and the rest was history.
So bulletin boards. My mom actually is the one who got our family into BBSing. It was when I was 10 years old, 1985. And she started dialing around to local BBSs and found some communities and got me and my sisters into BBSing as well. By the time I was 12, I was running my own BBS. And
Nice.
so I started running this BBS, and I was trying to think of a name. What should I call it? Well, why am I running a BBS? Just for the hell of it. My mom looked at me and said, "You're 12 years old. How about you go for Just for the Halibut instead?" I'm like, all right, fine. It makes for better ANSI yard anyway.
That's funny.
So it was Just for the Halibut BBS. And of course, this is back in the days when couldn't afford a hard drive, so everything was on a floppy drive. And floppy drives are not known for their data retention. And so the BBS would have to be reinstalled about every 6 months just because the floppy that it was on would die. And it eventually just got shortened to the Halibut BBS.
Yeah.
And so that's how Halibut became my identity.
Wow.
Fast forward to 1995. I've been using Linux for 2 years. I've been working at the library at Cal Poly as a system administrator there. And I found a Usenet article from some guy up in Redwood City in Silicon Valley, right near where I grew up, saying that he was looking for someone to help him set up what at the time we were just calling an internet connected BBS, but what I would now refer to as an ISP.
Yeah.
But I didn't know to call it an ISP at the time.
Yeah.
And so he got a 56K digital line at DS0 from some local internet provider. I don't remember where he got it from. And he brought in a bunch of phone lines and set up modems on a modem pool, and he needed help running the Linux machine in the middle that with all the PPP, the PPPDs on the modems, and then the upstream. And he had a /24, a class C of IP space. And so as in exchange for continued support, when I went back to college after that summer, I built up a server and stuck it in the corner of his garage where all of this stuff was. I grabbed one of his IP addresses and got to use his 56K line. And I had my own IP address on the internet and my own server on my own IP address. Again, now I would call this co-location, but I didn't know to call it that at the time.
Right.
I just had a server on the internet. And of course, I needed a domain name. So I filed the paperwork, which was free at the time, and registered halibut.com. And it wasn't until several years after that I started getting offers to buy it off of me, because my high water mark currently is $25,000. Someone has offered me $25,000 for halibut.com. I'm like, yeah, no.
Yeah.
That's an easy no. 2.5 million would probably actually. Now my standards are raising. 25 million would be an easy yes. It's that 250 to 2.5 million range that I would have to spend some time thinking about it.
Yeah.
So.
Wow. I remember in 95, I saw IBM came to campus and they loaded up a computer with OS2.
Oh, yeah.
And they got on the internet. And they went to Reebok.com. That was the first website that I ever saw, was Reebok.com. And, the guy was in there saying, well, in the future, you're going to be able to buy shoes on the internet. And I distinctively remember leaning over to my friend and saying, if I want to buy shoes, I'm just going to go to the shoe store and just buy shoes.
Yeah.
And
why would I buy something online?
Right. And that's the great entrepreneur in me. And here, what am I doing now? I'm doing video podcasting in my basement.
Yeah. Right. Yeah. No, it's all good.
Yeah. So when did you get your ham radio ticket?
So again, growing up in Silicon Valley, I got a job while I was in high school at a company called Haltech Electronics. For those who are familiar with the Bay Area, this is not Halted Electronics, or Halted Specialties, also known as HSC. That company, stayed around a lot longer, but it was very similar to Hall Tech. Hall Tech was up in Mountain View, right near the corner of Shoreline Boulevard and 101, kind of tucked in the corner of an industrial park back there. And I worked there during summers of 92 and 93, and then while I was a senior in high school as well, the 92-93 school year. And my boss there was a guy named Russ Rocket, N6 Mumble Mumble. For the life of me, I cannot remember his call sign.
Mumble Mumble.
But he talked to me about ham radio, and another guy I was working with named Greg. He talked Greg and I both into getting our ham tickets. And so we went up to Ampex up on the peninsula one Saturday afternoon after we had been studying with Russ, and we got our tickets. We got our technicians. So that would have been summer of 92.
Yeah.
And then I went down to Cal Poly San Luis Obispo for school starting summer of 93, and I joined the amateur radio club there, W6BHZ. Shout out to the big hairy zebra. I don't think I ever got president, but I was vice president of that club. I ran on a platform of, I promise to do absolutely nothing. Like what a vice president is.
Yeah, exactly.
I am a name you can put on the form that will allow to get the university to allow the club to continue to exist.
Right.
Yeah. So
you're just a signature at that point.
Yeah. But no, it was a great club. We were super active, had a lot of fun, did a lot of field days, did a lot of other contests and things, and a lot of really well-known alum from. Well, I don't know about well-known, but several alum from BHZ have gone on to do some great things. Anyway.
Cool. Yeah, very cool. So we're going to talk about common mode chokes. And, if anybody has watched the internet, you've watched Ape, Smoking Ape, and the Coffee and Ham Radio guys talk about toroids and all the things that toroids do and the great things that you can accomplish with toroids and ferrites and whatnot. But one of the things that, first let's define common mode chokes, toroids, ferrites. What would you? Let's break down those.
Define those terms.
Yeah, define those terms, and where would you use each one based on it's a noun versus a verb versus a whatever.
Yeah. So let's start with toroid, because that's kind of the most fundamental one. A toroid is just a mathematical shape, right?
Right.
A toroid is a donut, right?
Yeah.
You take a circle and here's an axis. You take a circle here and you rotate that circle around, and it just creates a circle of a circle.
Yeah.
That is a toroid. And so when we refer to a toroid, what we mean is a toroidal shape lump of something. The most common something that we are referring to is a toroidal shape of ferrite material or ferrous material. Ferrous meaning that it has iron in it. Not just calling it iron, meaning that it has other stuff in it as well.
And it's a mixture of elements, right?
It's a mixture of elements, yeah. And it kind of turns it into this kind of ceramic baked thing. But the mixture of those elements is very specifically designed to have a low, and I'm going to use the word impedance, but there's a different term for it, a very low impedance to the magnetic field, to magnetic fields, right? So it is a material through which magnetic fields travel very efficiently. Okay.
Got it.
And so that's a ferrite material. Ferrite can come in other shapes, not just toroids. But when we are mostly we use them in a toroidal shape.
Yeah.
Now, how do we use toroidal ferrites? We can use them in lots of different ways. Generally, when you stick ferrous material or ferrite in the magnetic field of an inductor, what that does is it greatly increases the inductance of that inductor. When you hear the term air core inductor, that means you don't have any ferrite in there. You're just using air or open space as the medium through which your magnetic fields are traversing. By sticking ferrite where those magnetic fields are, you're going to make those magnetic fields way more efficient. Efficient, probably both of those.
Yep.
And it greatly increases the inductance of the inductor that you just made.
Yeah.
So how do we use that? We use it in lots of different ways, but the one we're going to be talking about tonight is called a common mode current choke. Okay, so we've talked about ferrites and toroids and inductors. What the heck is common mode?
Yeah.
So common mode as opposed to differential mode. Okay, that doesn't help a lot. So let's describe both of those terms. When you think of a transmission line, like either a parallel line, feed line, or coaxial feed line where you've got a shield and a center conductor, or even just two wires that you've got DC power flowing down, right? So your DC power cord is also a transmission line because you're transmitting power down that line.
Yep.
You've typically got two conductors, and current is flowing that direction on one of the conductors and that direction on the other conductor. This current can be DC, as in the case of a 12-volt power supply like we talked about, or it can be RF. That part, what the frequency of the of this current is irrelevant. What is important is the fact that you've got some amount of current going that way and you've got some amount of current going that way.
Yep.
If those currents are exactly the same amount, then that is called a differential mode current. Okay? Because you got currents going in different directions. Neat trick. If you put differential mode currents on two wires going through an inductor, so you have, instead of just one wire coiled, you have two wires next to each other that are coiled up.
Yep.
If you have currents going in opposite directions, well, that current makes a magnetic field, right? You got the right-hand rule. So if the current's going that direction, the magnetic field goes this way.
Goes around.
Right? But if I've got current going that direction, the magnetic field goes the other way.
The opposite
and
way,
so if
right.
I've got matched currents, the magnetic fields cancel out. All right? So differential mode currents through an inductor generate no magnetic fields. So there is nothing for the inductor to do anything on. Differential mode currents through an inductor are completely transparent.
Okay.
So what is common mode? Well, if on these two wires, if I've got 1 amp going that direction on one wire or both wires or whatever, it doesn't matter, but it's only going that direction, and there is no matching current for it this direction. All right.
Okay.
If that is the case, then that is called common mode, right? So now, because it could be two currents going in the common direction down the wire, or it could be on one wire, it doesn't matter. But as long as it is not opposed by current going the other direction, that is called common mode current.
Okay.
Right.
Okay.
And so now if you run common mode through that exact same inductor, that does result in a magnetic field that the inductor will act on. And now that common mode sees inductance. And inductance looks like let me think about this, low pass filter.
Okay.
All right. So you can pass DC through an inductor. DC is the ultimate low frequency. It is 0 hertz, right? Always think of DC as 0 hertz AC. So DC is your ultimate low frequency. DC will pass right through an inductor. So it will pass low frequencies and it blocks higher frequencies. All right. Okay. That's what an inductor does. The capacitor is the opposite way around. Capacitor will block DC, but will pass AC, will pass higher frequencies. So okay. They are opposites of each other. All right. So now, what is a common mode current choke? I've been trying to get to that. It is a magical device that we want to put in our feed line that will allow differential mode currents like what you are transmitting toward your antenna to pass right through it. But if that differential mode goes up to your antenna and it hits your antenna, and your antenna is not perfectly balanced. One wire is a little bit longer than the other, or one wire is closer to a metal roof of a building or a metal pole or whatever. They're not perfectly balanced. Spoiler, there's no such thing as a perfectly balanced antenna. If they are not perfectly balanced, you are going to get some amount of imbalance in the current consumption. So your perfectly differential mode power going up the line is going to get reflected back. Some of it's going to get reflected back as common mode current. Okay,
because it's in. Well, yes, yeah, because it's coming in the same direction, right?
So the differential mode being transmitted to your antenna is being pushed like this, right?
Right.
They're going back and forth, but they are balanced,
right?
And then it's going to get up to the antenna and hand wave. There's the impedance of the antenna itself, which is the impedance between the two lines of your transmission line. But then each end of that transmission line also has an impedance into open space, into free space.
Yep.
And the impedance of those each side to free space is what is actually imbalanced in to get common mode. That's what generates common mode current. So if one side of it has an impedance to free space and the other side has an impedance to free space, and if those impedances are not exactly the same, then you're going to get some common mode current returning back down your feed line.
Right.
This is different than an unmatched SWR. Like if you've got SWR, that's also considered reflected power, but that reflected power is differential mode.
Okay, so yes, explain that. Yeah.
Okay, so I can't. We don't have time here to that. I'm going to ask you to let me wave my hands.
Yep.
And state as a given that SWR is caused by differential mode reflected power. That's coming back down the line in differential mode. Common mode current chokes will not fix your bad SWR.
Oh, okay. Yeah, right.
That's the takeaway.
Right, yeah.
A common mode current choke will not fix your bad SWR.
Right.
Okay?
Right.
That's actually a lie. It may, but for different reasons. If you have a bad SWR because your antenna is like inductively matched in certain ways, adding a common mode current choke can anyway, we're getting complex here.
Right.
The common mode current is a different problem than what you will measure with an SWR meter. SWR meters are only measuring differential mode power going that direction and differential mode power going that direction. All right. Common mode currents are different than a high SWR. Common mode current is current that is coming down on the outside of your coax.
So let me ask you this that I've gotten asked before by a new ham. I have a tuned 20-meter antenna.
Tuned as in resonant?
Resonant,
okay.
Right? So that person has put this antenna up above, quarter wave or half wave above the ground, and the SWR is 1.0, right?
Okay.
On their meter, right?
Okay.
But they are still having common mode come down and getting into their microphone and into their radio, and they're being shocked whenever they PTT. So
exactly.
Right. So there are other things at play there that that I'm sure that you're going to get into.
Yeah. So that's kind of what we were touching on, right?
Right.
If the antenna is not balanced, meaning that it is not like both sides of the feed line are not seeing exactly the same thing.
Yep.
You can have a 1-to-1 SWR. So also measuring 1-to-1 SWR at the end of your feed line doesn't mean you have a 1-to-1 SWR at your feed point.
Right. Because that coax could be resonating and could be masking that SWR at your feed point versus what your radio is seeing.
It gets worse than that, or it's even simpler than that. I'm going to use a big number here because it'll make the math easier. But let's say you've got a long enough piece of coax that you've got 3 dB of loss, just power turning into heat.
Yep.
right? So I've got 3 dB. I put out 100 watts. I've got 3 dB of loss. I've lost 50 watts. I've only got 50 watts at my antenna. And the antenna is a dead short, right? Okay. And so now that 50 watts is all of it is being turned around and coming back down the antenna. Well, guess what? There's another 3 dB of loss. And so you put out 100 watts and you're measuring 25 watts, right?
Right.
That's a 4-to-1 ratio. I don't know exactly what that turns into in SWR, whether that's a 4-to-1 SWR or a, no, because it's the other way around. Like 100 watts and 0 watts would be a 1-to-1 SWR. So I never fully understood how to do the SWR math, but you've got, if you're transmitting into a dead short, you would expect that to be like an infinite SWR, but you're not going to see infinite because of the losses in the coax.
Right.
So,
right. Because the coax is part of your antenna.
Yeah.
As much as you don't want it to be, it's part of your antenna.
Yeah. Actually, that's one of the things that a common mode current choke can help with, because all right, so we were talking about differential mode and common modes.
Yes.
On coax, how many conductors do you think there are in a coax?
Well, the plain or the new ham answer would say, I think that there is 2.
No, yeah.
Or
I got the center conductor and I got the shield.
Right.
It's 2 conductors.
Because whenever I whenever I create my first dipole, I put one part of the dipole on the center conductor and I put the other part of the dipole on the shield, right?
Yep. Yeah, exactly. So obviously there are only 2 conductors in a coax. That is true, but there are 3 paths for current. So we talked about differential mode and common mode. Differential mode currents necessarily travel on the inside of the coax. One of the currents is on the center conductor, and the return currents are on the inside of the shield.
Okay.
And Faraday cages being what they are, Gaussian laws and other names that I remembered from college, but I couldn't explain to you now. All of your differential mode currents will necessarily travel on the inside of your coax. Common mode currents will necessarily travel on the outside of the coax. Okay. So let's say we got coax and we go up to a center divider, a center insulator, and we just take the center conductor and pull it out this way for a dipole and the shield out to this way on the dipole. And I don't put any other electronics at that center point.
Okay.
All right. If that dipole is perfect, then all the currents will go in the right place.
Okay.
But if they are not perfect, then you've got a third wire hanging off of that antenna. Actually, even if they're perfect, I think you still have that third wire hanging off of that antenna, which is the outside of your shield.
Okay. Yeah.
Right.
Yep.
And so you're still got, your 2 resonant pieces out here, and presumably your feed line, the outside of your shield is going to be super long, so it's not going to be resonant. At least that's the assumption, and it's not going to be resonant, and therefore it's going to be a higher impedance than the resonant piece of wire attached to the shield at the antenna. So this is going to get most of the currents, and very little of the current's going to come down your coax.
Okay.
That's the theory.
Yep.
But what we would really like to do is to be able to disconnect the outside of that shield from the antenna, right? So that the only 2 places for current to go are the center conductor connected to this wire over here and the shield connected to this wire over here. On the inside of the shield connected to this wire over here.
Right.
We don't want current to come up from the inside and then be able to go down the outside of the shield and treat that as a third wire of our antenna.
Yeah.
So what we want is a device that we can put at that feed point that will allow the differential mode's currents to pass through it, but will block the common mode current. And as we've discussed earlier with those inductors, putting an inductor up there where your differential modes can pass right through it, but your common mode cannot pass back down, or rather it's a very high impedance to common mode.
Yes.
That will prevent that reflected current coming down and getting into your shack and making your microphone hot, right? And zapping you every time you touch the microphone while you're transmitting. So that person that you were talking about who commented that I've got RF in my shack, the solution to I've got RF in my shack is to put a common mode current choke at the feed point of your antenna.
Yeah.
Right? So that is one of the most common places to put a common mode current choke. The other common place to put a common mode current choke is right at the back of the radio, because I have disconnected my antenna from the outside of my coax, but now I've got this giant wire that is the outside of my coax that comes down to my shack and ties into my radio. Now, admittedly, it ties into ground, which if I've got a perfect ground, any current that's picked up on that wire looks like an antenna, right?
Right.
That is an antenna. It's a long random wire antenna. And it's going to pick up RF currents, and it's going to come down into your shack. And if there's any impedance between the antenna port on your radio and the ground for your radio, that impedance, that current coming down that wire is going to go through that impedance and create a voltage. And that voltage will show up in your receiver. Remember, receiver sensitivities are down to like minus 120 dBm, right? So minus 120, or 10 to the 12, right? 10 to the 12th power milliwatts. So it doesn't take much receive power coming down this wire to create much of a voltage that your radio receiver will be able to detect.
Yeah, right.
And so that's how you get noise, or that's one way you get noise in your receiver, is the feed line acting like an antenna, receiving RF energy, either from what you're transmitting, or if that feed line runs next to some very cheap LED lighting and it's got a switching mode power supply, or dryers for some reason, or notorious noise generators. I'd never understood why that happens. But like if your dryer's generating a bunch of RF hash, anywhere you've got these really cheaply made switching mode power supplies, they will create all of this RF noise.
Your AC or your heater blower.
Yep. Yeah.
That one's a horrible one.
Yeah. And so anywhere you've got these, again, because it's a switching mode, that one's probably pulse width modulated, just to slow down the fan, right? Anywhere you've got these poorly made or cheaply made switchers, they're going to generate all of this RF noise. And if your coax runs near that, it's going to pick all of that up. And that's going to come into your radio, and whatever impedance is between your antenna port and your ground, that is going to create a voltage, and that's going to show up in your receiver.
Yep.
So another common use for a common mode current choke is to put it right at your antenna, right at the antenna port of your radio. And that, again, disconnects the shield of your coax from your radio, the outside of your shield from the radio. And it can remove some sources of noise.
Yeah. Some, not all.
Not all. Because a lot of times your antenna is also going to pick up that RF noise.
Right. It's the biggest culprit of noise.
Yes. You're designing it specifically to pick up RF signals.
Right.
Right.
I had somebody say, well, I've got all these static crashes and I put a bunch of ferrites on my line and I still hear static crashes. And I'm like, well, let's think about this for a minute.
Lightning gonna light.
Hopefully you are not operating with the lightning around you.
Yeah, not near you. Not nearby, I hope.
So, okay. So we've got our feed line, we've got our antenna, we've got our radio, and we've got our ferrites, so we could go down the rabbit hole of different mixes, but this is one of the things that you have developed is a board to help test some of these different mixes or not mixes, but like ranges of where a ferrite is effective and where it's not effective, right?
So that is one application for what the common mode current choke test rig, TM, that is one of the things that you can use it for. So in short, what the common mode current choke test rig does is, well, let me back up.
Yep.
You're familiar with what a nano VNA is?
Correct.
Right? Okay. So hopefully everybody knows what a nano VNA is. And if you don't, I'll give you a quick summary. It's a 2-port device. It transmits a very small signal over here, but of known amplitude and known phase. and it sends that signal out through port 1. And then it listens for reflections of that signal coming in port 1 and measures the relative amplitude and phase of that reflected signal coming in port 1. And it also measures the relative amplitude and phase of that same signal coming in port 2 for a through measurement of the signal, right? So then once you have, I know what I transmitted and I know what I received on both of these ports, you can do hand wavy, whoa.
Yeah, hang on. I'm trying to bring up the, I got to get a better setup on my
OBS.
Yeah, OBS. Yeah. Let's see. Let's go this one. Here we go. There we go.
Okay, very good.
Nano VNS or Nano VNA.
So anyway, once you have, I know what I transmitted, I know what I received on both of these ports, then math, and you can measure a whole lot of things about the device that's hooked up to it. And one of the things that you can measure is, I sent out so much signal here, and what is the relative amplitude coming in on this port here, i.e., how much gain or loss does this particular device have? And that's very useful. Oh, and over a frequency range, right? So like I can do this anywhere, from 3 megahertz to 30 megahertz. So I can hook up a filter to my Nano VNA and measure S21 log mag, and that will measure the magnitude of the signal being sent from one port and received by the other port. And so it'll say like, minus 10 dB, minus 20 dB, minus 25 dB or whatever, at all the different frequencies. And it'll give you a graph of how much attenuation or gain, if it's an amplifier, of that filter, right? So you can you can measure the shape of your filters.
Yeah.
That's what a VNA does. That's kind of in a nutshell, that's what a VNA is doing for you. But VNAs are measuring differential mode currents, right? It's measuring the inside of that coax. If you hook up a common mode current choke directly to a Nano VNA or any VNA, it will look like a piece of coax. It'll say 0 ohms of attenuation, assuming it's good coax.
Yeah.
Right? There is no attenuation here. It's just a straight through wire. Right?
Okay. Yep.
And so the fact that there's a choke going on the outside of that coax is completely transparent to that VNA. It cannot see it because it can only measure what's going on the inside of that coax. So I made a kit. Nope, that's upside down. Nope. Yeah, whatever. Anyway, I made a kit that is this small circuit board and a bunch of connectors on it and a couple of switches and some other things. And when you put this together, what it does is it takes the differential mode, you hook it up to a VNA, right? So it's got two input ports.
Let me share my screen here.
Okay. I don't have one assembled in easy reach, unfortunately. Otherwise, I'd show you an assembled one. Okay, I see it on YouTube. I don't see it in Zoom, but that's okay.
How about now?
Okay, very good. So the what we're looking at here is the output side of the board. If you can see here the SMA ports right above in the center, kind of the goldish colored ones right in the center. Right above it look like the backside of an SMA soldered on the other side of the board. Those are the input ports, and so you connect those up to a VNA.
Okay.
And then on the output side, you have all of these different types of connectors. So no matter what kind of connector your common mode current choke has, whether it's an SMA port, a BNC port, an N port, or a PL259, or just bare wires that you want to wrap around a banana plug, right? Like no matter what kind of connection your common mode current choke has, you'll be able to connect it to this test rig. And what the test rig does is it takes the differential mode currents from the inside of the cable from the VNA, and it makes it common mode, and it puts it on the outside of the coax. Like literally all it's doing is taking the center pin of the cable going to the VNA and attaching it to the shield of all of these connectors.
Ah, okay.
Okay. And so now your signal is going on the outside of your coax. And then you hook up your common mode current choke to it. And the attenuation that is caused by the inductor in that common mode current choke will be measured by your VNA.
Okay. Got it.
All right. So when you hook up a common mode current choke to this test rig and then a VNA to the backside, it will allow you to actually measure the effectiveness of your common mode current choke. Because there are so many designs out there of, put this many winds on this kind of a toroid and you'll see this kind of attenuation or this much impedance.
Right.
And it is not easy to verify that. It is not easy to measure that. And there's a lot of conventional wisdom about, this type of design is better than that type of design. This mix is better than that mix or whatever, right? I say poppycock to all of that. I say build it, measure it, change it, measure it again, figure out whether it's better or worse, whether you should continue going, whether you hit the point of no return and you've gone out the other side and you want to back off. Like, measure your common mode current chokes.
Right.
And with this kit allows you to do that.
So whenever, a long time ago, before we had something like this, this is what a bunch of Elmers had told me, is you're not going to get the amount of impedance out of a ferrite unless you wrap that thing at least 7 to 10 times, which could be true, but we at the time had no way of figuring out how much inductance you were getting, right, whenever you were wrapping toroids, right? Or wrapping your cables through a toroid.
So there is math you could use to try and calculate it.
But it's very hard. It's like math not for me. Maybe for you, but not for me.
Yeah, it's not as hard as you think. But the problem is that there's no way to verify it. You're going on faith, right? Like if you wrap wire into an inductor, you can do the math. That's basically what you're doing with the coax. You can do the math and figure out what the inductance is, but then you can go measure the inductor. Yeah. Right? There are inductance meters, and they're not that expensive. And you can go measure it and validate it. And then you can kind of, tweak it by pulling it apart or pushing it closer together to increase or decrease the inductance. And you can do that. That is hard to do with a common mode current choke. That kind of measurement is difficult to do with a common mode current choke, especially since it is so affected by the frequency you're operating at. And so the meter that you might use to measure the inductance of your common mode current choke is probably measuring in the kilohertz range. Yeah. And that's going to be very different than in the megahertz to tens of megahertz range.
Right.
Because then you start getting into, what's the mutual capacitance between these turns? And now you've got the capacitance and the inductance in parallel, and that makes a resonant circuit. And you can really see the resonance on these things. If there's too much mutual capacitance between your turns, you will see a very sharp dip in the impedance graph, the S21 log mag graph. Like you'll see a very high attenuation in a very narrow frequency range, right? This very sharp, deep attenuation, but only at one frequency. And then it's really bad everywhere outside that frequency. Whereas for a, HF common mode current choke, you would rather have less attenuation, but flatter across the entire band, right? And so where do you start getting those capacitances? Like getting measuring the capacitance or calculating the capacitance becomes real tricky. So having something to be able to measure the actual response of your common mode current choke is something that I wanted, and I thought about it, and I'm like, this wouldn't be that hard to make. And I built a couple of boxes, and I used it to make some measurements, and I presented on the whole concept of common mode current chokes at a QSO Today Ham Expo a couple of years ago. And then people asked me, great, can I buy that kit? And I'm like, no, I'm still full-time employed. I don't have a business, and I don't really want to get into that business. And then just like a few months later, I ended up leaving my employer and starting a business. And I'm like, oh, okay, I guess I am in the business of selling kits now. So let's go make this kit. And this was the first product, and currently still the only product that I sell. So
whenever we go out and we look at common mode chokes and ferrite material, there's different mixes, and they have standardized on different mixes. So you'll have, just off the top of my head, you'll have a mix 31, you'll have a mix 43, you'll have a mix 63, and I think is it 63?
61?
61, maybe it's 61, and then something in the 70s.
I want to say like 72.
Yeah.
Yeah, I'm going from memory on these mixes as well. We might 43 and 31 are definitely correct. The other two I'm a little
me too.
On.
Yeah. And the most common one that you're going to see in an HF, like if you get a mix kit from what is that that company? Somebody said it here in the chat.
Starts with a P.
Somebody put it in the chat. They make the mix kits that a lot of people buy. Don, put it in the chat. But anyway, Polymer Engineers. They make some RF.
Yeah, Polymer.
Yeah, make some pretty good RFI kits. Yeah, thanks, Dan. That you're going to get a mixture of probably mix 31 and mix 43.
Correct.
Ferrites in that.
Those are the two commons.
Yep.
So let me explain what mix means. Mix just refers to the recipe of iron, ceramic, and other elements that go into the ferrite. We kind of hand waved at it. Different elements give it different properties, and 43 and 31 are hand wavy. 31 is better for lower frequencies, like the lower end of the HF band, and 43 is better for the high end of the HF band. Spoiler alert, they're both really good. If you're trying to build a 10-meter choke and all you have is a 31 mix, don't freak out. Build it. It's going to be fine.
Yeah.
They're really not all that different.
Yeah. I think in all of our HF stuff that I've used ferrites in common mode or built common mode current chokes, they've all been mixed 31.
Yeah, it'll be fine.
Yep. So, yeah, go ahead.
Nope, go for it.
I was going to say, so, let's say I've got a bunch of things that are ferrites that I've bought off of Amazon. I bought them at this ham show, and some dude,
they're unmarked.
Some dude, some chick said, "Hey, yeah, these are great. Put these on your coax for HF," and he's got a dime a dozen, right?
Yeah.
So this board as a kit with your nano VNA, you'd be able to buy that ferrite or that toroid or whatever you want to call it at that ham show for 10 cents and bring it home and verify that it is what it's supposed to be, right?
So this kit will not tell you what the mix is.
Right.
But it will tell you whether it's effective or not. At which point, do you care what the mix is?
I don't.
See, that's my personal philosophy. If you really want to know what the mix is of a particular thing, your best bet, if you have a good feel that it's either going to be 43 or 31, but you just don't know which one it is, all right, wrap some wire around it, measure the inductance. They, the same number of turns on each of those mixes is going to result in a different inductance. Wrap some wire around it, measure the inductance, and hopefully that your measurement will be very close to one or the other, and that'll give you a pretty good indication of what that mix is. But if you're just trying to use it as a choke, build the choke, measure it with this thing, and if it's effective, just put it up and don't care what the mix is. It doesn't matter.
Right.
As long as you can measure and say, yep, I got 25 dB of loss across the bands that I care about. Good enough. Put it up.
Yeah, and as a society, we have now companies have put us into a box on, it's got to be a 31 or a 43. Like you said, I don't care. As long as it does what I need it to do, I could care less if it's, a mix 21 and a half, whatever the case may be. As long as it does what I need it to remove that common mode current on my line, who cares?
Yeah. Now, the one exception to that is that this common mode current choke test rig is not going to be able to measure saturation. So you will not be able to measure how much current does it take to saturate the ferrous material?
Oh,
What I don't know is whether some mixes are better or worse at saturation than others.
Yeah.
So that might still be a gotcha on that. But in general, like 43 and 31s, they're both, add more material, stack another toroid on your choke.
Yeah.
And you'll, I'm not sure if it's literally double the current handling capacity, but it's close to it.
Yeah, don't put 1,500 watts through the T160 toroids, boys and girls.
No. Yeah, exactly.
So I would assume that, if I'm a newbie to all of this, that and I had a bunch of ferrite material here at the house, and I was going to my local ham fest, and I wanted to pick up some toroids, that I could buy this kit off of your website, put it together, and then I'm assuming there's some instructions that you have on how to get started and how to measure your first toroid.
Yep. So I'm going to answer that question by also answering another question.
Sure.
Andy in the chat room was asking, where can he buy one of these? I will go ahead and throw out the pitch now. Electronics.halibut.com is where all of my products can be found. Electronics.halibut.com. So you were asking about, is there documentation on how to use this thing? Electronics.halibut.com/docs, DOCS, all lowercase. So that's the web page. And if you just go to electronics.halibut.com/docs, that will take you to the documentation.
Yeah, very good.
So there are assembly instructions and a user guide there. So the assembly instructions talk about how to build the thing, and the user guide talks about how to use it.
Yes. Very cool. Yeah. Talks about, here's the schematic, detailed operations. Yeah, perfect. So this is great for the newbie out there wanting to pick up some ferrites for cheap and coming home and testing them and making sure that they are what that person said, and if you want to use them on your feed line, right?
Yeah.
Or anything. You can use it. I have them on my power. I have them on my feed line. I put them on everything.
Whoever just bought a kit, thank you. I get a notification on my watch whenever an order comes in.
Oh,
I just
nice.
got a notification.
Very cool.
Thank you.
Very, very cool. You also, we've got about 8 minutes left, and I'm sure that we're going to go over here. But you have some other cool things that you're working on. Tell me about this open headphone standard that you are working on.
So go to ohis.org.
ohis.org.
Yes.
Okay.
So first off, amazing that I was able to find a 4-letter .org domain that hadn't been taken yet.
Oh, yeah.
ohis.org. I just registered that recently. So the Open Headset Interconnect Standard is a open standard that I am proposing to the industry. We got standards for power, 13.8 volts. We got standards for RF, 50 ohm coax. We do not have standards between the user and the radio, right? And so every manufacturer has a different connector, or even if they are using the same connector, there are different pinouts. And, some radios use electric microphones, some use dynamic microphones. Some of the audio outputs are speaker level, some are headphone level. If they're speaker level, are they ground referenced or push pull? I'm just like, there's just literally no standard. And so if I want to take my headset from my radio to your radio, and this is especially important in multi-user environments like a club shack or an EOC or a contesting event. If I want to be able to take my headset, by the way, all the headset manufacturers are also different. Yeah. So if I want to take my headset to your radio, we need to have an adapter that is unique to the pairing of my headset to your radio. Yeah. And you end up in this multi-user environment where you have all these different headsets and you have all of these different radios. And for anyone to be able to sit down at any radio, you need to have a full mesh of adapters. So what I do is I am proposing this electrical and physical standard called OHIS. And in the ideal world, the manufacturers would adopt the standard directly, and your radio would have an OHIS port on the front of it. And your headset would have a cable that you could buy that has an OHIS port on the end of it, or OHIS jack on the end of it. And you just be able to plug that headset straight into that radio, and you're done. And you're done.
Yeah.
And into any radio. But I realize that we are a long ways away from getting manufacturer adoption. So instead, we are starting out by making adapters. And how are these adapters better than the adapters that I just told you about? Well, the idea is that with my headset, I buy one adapter that is unique to that headset, that stays with that headset, and it converts whatever that headset has to the standard. And that is the last adapter I ever have to buy for that headset.
Right.
And then I go to the radio, and again, I buy or build, this is an open standard, an adapter that is unique to that radio, and it converts whatever that radio has to the standard.
Yes.
Right. And so now I have a standard port right next to my radio. Ideally, it would be in the radio, but for now, we're dealing with adapters. So there is a port next to my radio that is the standard port, and I've got a port on my headset that is the standard port, and I can now plug any headset with that standard into any radio with that standard.
Yes. We need this. We need this in the contesting world, in multi-ops.
And there's a second order. Thank you very much. So yes, we absolutely need this. Contests like field days would be fantastic for this. So I am very close to having these ready for sale.
Oh, that's awesome.
I've gone through an early adopter program. I sold about 25 of them to users on my mailing list, and I've gotten very good feedback, a few, minor tweaks and changes. And I've bundled up all of the design files and sent it off to the manufacturer right before field day. And I am waiting to get a quote from the manufacturer based on everything I've sent them. Once I get that quote, I'll be able to set list prices and hopefully give them the go-ahead to start making these in, sale to the public kind of quantities. What you're looking at here is the standards document that I need. It needs work, but it's mostly technically complete.
Yeah.
This is the standard, and this is an open standard. And I really try to kind of keep my standard advocacy separate from commercial selling of adapters, because I am in both of these camps. The standard advocate in me would absolutely love other companies to be making adapters and price me out of the market, right? Make better adapters cheaper than I can. I know there are companies out there that are scaled up. I'm just one guy, right? I'm one guy that needs to pay a mortgage. So like I'm going to charge what I have to charge. I know there are companies out there that can do this better and cheaper than I can. Please come into this market and do this better and cheaper than I can and price me out of these adapters, because that will encourage adoption. And I absolutely want adoption. Then there's the other side of it, the commercial side, where I'll sell adapters as long as I can and have to encourage adoption. But what I really want to do is make devices that go between the radio and the user. Right? This is what we were talking about a little bit before the show. We're going to go a little long. Is that okay?
Oh, yeah.
Okay. So the first one that I'm working on, and literally was working on today and got it working today, is what I'm calling the contesting console. The contesting console is a device that you plug two headsets into, and I call them logger and operator, and then you plug the console into a radio. All right? So we've got two users and one radio.
Yep.
Each user has their own independent 4-channel mixer. And the inputs to that mixer are the radio's output audio, the other user's microphone audio, so you can hear the other user. You have an intercom. You have your own microphone audio, so you can get a little bit of side tone, so you're not yelling into the microphone. You can hear yourself.
Yep.
And then the fourth one is what I call ambient, where there's just a MEMS microphone on the mixer console that's picking up audio from around you. So like if somebody walks up to the table where you're operating and you want to talk, you want to be able to hear them, instead of having to interrupt what you're doing and take your headphones off and look up at them, you can just turn that knob up. You just turn that where's my hand? There it is. Turn that knob up a little bit and you'll be able to hear ambient, what's going on around you.
Yeah.
So you've got radio input, the other user's mic, your own mic, and then the ambient. And you can adjust your own mix of that. Both users have their own mixer to adjust their own mix. So now the logger and the operator can talk to each other. Was that a KN or was that a KM? You know, whatever. You can have those conversations without having to pull your headphones off and talk to each other. And then whichever user presses their PTT, that audio, their microphone audio, gets sent to the radio.
Yeah.
And the other one's is muted. And so it's like this perfect contesting console, right? And that's what it's meant for. I have built this without the OHIS side of it, something that it's built for PC gaming headsets on one side and then my Yaesu FT920 on the other. So it was built for a very specific use case, and it works wonderfully. We've used it at Field Day for the past probably 5 out of the last 10 years, and it's just a joy to use. And so as soon as I started doing the OHIS stuff, I'm like, this is going to be the first thing I build that uses OHIS.
Yeah.
And I had a prototype made a couple of months ago. I got the prototypes from the board fab, soldered it up, plugged it in, and I got no audio out of it. And I'm like, I can't work on this right now. And I set it aside. And I started working on all of these adapters, getting those out. Today was the first day that I was able to get back to that contesting console. I found where the problem was that was causing the no audio. It's one component. It's the MEMS microphone. I did something wrong with the MEMS microphone. So I just pulled the MEMS microphone off of the board, and the whole thing works great now. Yeah. So like I won't say it's ready to go because there's a lot of productization to go, but the circuit works.
Yeah.
Right? Like,
yeah. Your open headset standard is something that the contesting world has not embraced, and is a pet peeve of mine. Of whenever I go into a contesting station, I want to use my headphones that I know that are comfortable,
that have your ear goobers in them.
Exactly. And that's one thing that I actually hate, is whenever I go down to my contesting station and somebody has been sitting in that radio room sweating their ass off, right? And I put on the headphones. I mean, sometimes I wipe them down if we're in the heat of the moment. I don't, but man, is it disgusting. Yeah. You know? And I would love to just take my Heil headphones with my microphone and have your adapter at the end and just snap in there. And I can also see this where you've got, Matt says butt sweat. Matt knows because Matt contests with me.
Moist ears suck.
Yeah.
Word.
Matt and I at 3 o'clock in the morning on the radios goofing off and in the radio room, and it's 110 degrees. Ain't fun. But
I will
anyway,
not use another man's cans, says Overlanding for fun.
Yeah. So,
yeah.
And even like if you have multiple radios, I mean, I just did a video 2 weeks ago about all of the adapters that I have for my headphones. I have different adapters for different headphones for different radios. I own 4 different radios, and I own 3 different headsets. Guess what? I have 7 adapters.
Yeah.
You know?
Yeah, because you need to have a full mesh.
Exactly.
Between all the different headsets and all the different radios.
Yeah.
And if you're in a single user environment where you've got one headset that you use everywhere, great. Use the direct adapters. The OHIS is overkill in that situation, right? But if you've got multiple users or multiple headsets and multiple radios, OHIS starts helping you out. Yeah. And especially in a multi-user environment, that's really where it shines.
Yeah. The being able to talk to one another during field day or whenever you're contesting is genius, because there are so many times where you're trying to, you're doing one of these things and you say something and they haven't pulled their headphones off, so then you repeat yourself 4 different times.
You need an intercom.
Yeah.
So contesting console is that, and I've got it on the Workbench right over there, and it is working, man, and it is glorious, and I am looking forward to selling it. Yeah,
that's going to be a hot commodity. I mean, that's great. So, I love this open headphone standard on just make everything the same, and it's just all compatible. It's
tell
great.
all your radio manufacturers.
Yeah.
Go up to Yaesu when you see them at the next ham convention and say, "Hey, have you guys considered adopting OHIS, Open Headset Interconnect Standard?" They'll probably go, "Well, I don't know what that is." It just ohis.org. Go check it out. I think you guys should adopt it. That would be a really good thing, right? Just start talking to your radio manufacturers. See if we can give them a little pressure.
James says, "Can the mics the MIMS mic be used as a PTT mic?" I'm not really sure. Does you know what a MIMS mic is?
No, MEMS, MEMS. It micro electromechanical something. Anyway,
gotcha. Okay,
it's a microphone in a little tiny chip. It's what your cell phone uses and everything else.
Oh, okay. Gotcha.
But I put a MEMS microphone on the board for this as the ambient microphone. No, the ambient mic will never be routed. It does not currently have a way to be routed to the radio, and that's kind of not what it's meant for.
Okay, gotcha. Let's see some of the other comments up here. Peeps back on toroids and ferrites. Possible stupid question, but when winding toroids, is there a difference between using standard copper versus solid? That is a very good question. Oh my gosh, that's a great question.
I don't think so. That's going to be more a question about resistance and skin effect and whatnot. Wow. Okay, I just got 2 orders in very quick succession. I think I've sold 4 kits just during this 1 hour. Thank you.
Thanks, everyone.
Thank you so much, everyone. I really appreciate it.
This is part of like getting all this cool stuff out in the open and getting people aware. I mean, it's one thing whenever people walk by your booth at Hamvention, right? And I do this too. I'm guilty of, I will see the coolest thing probably in the world, but I just skim by that booth because I'm tired or my eyes just glaze over.
I don't want to get them started.
Right.
They're going to start their pitch.
Or I just, like my eyes just glaze over. Yeah. I'm just like, oh, that's kind of cool. All right, next thing. Or my ADHD kicks in and I'm just like, I can't comprehend anything right now. I just have to walk, you know?
Yep.
And so now we're getting into the details of all the cool things that happen in ham radio that you might not know about, you know? So
the MEMS mic cannot be used to go to the radio.
Peeps also says, I'm winding a 1-to-1 chokes and making a 4-to-1 Ballon right now. I've been working on it for a few days. Thought I might ask since I got
Ballon. Okay. So
the
term Ballon is so ill-defined. That's why I use the term common mode current choke. Common mode current chokes are sometimes referred to as Ballons incorrectly, although technically it's correct because it can make an unbalanced signal a balanced signal. QRP choke. Yeah. Kyle.
So if you don't know, Josh was on my stream a week ago, and he has got a common mode current choke in his repertoire. If you need a common mode current, go to Josh's website, Tuflin.
Oh.
And if you need some QRP stuff, go to his website. Yeah.
We actually had Josh, did you give one of those to Vince VE6LK?
Probably.
Because at Hamvention, because we had it at the table and we're using it to demonstrate the common mode current choke test rig.
There you go.
I also had a Pactena common mode current choke and a bunch of cable and snap-on ferrites that you could use to play around with chokes and see how their response curve changed as you added turns and removed turns and put the ferrite on and all that kind of fun stuff.
Yeah, that's a great website. It's got a bunch of cool stuff.
Yeah. So Josh says yes. So thank you for giving that to Vince, and we were able to demonstrate it, and it performed quite nicely.
There you go. He's already tested it.
Yes, it's already tested. It worked quite well. I think it was about 25 to 30 dB of attenuation across the band, which is what you want.
So we're talking about balance and balanced versus unbalanced, right?
Yeah. So, okay, the term Ballon, common mode current choke is often used is often called a Ballon, which is kind of true. It can be used that way. Then there are also impedance matching transformers. So if you hear the term a 4-to-1 balun, that is also a balun. Or actually, a 4-to-1s are usually built as ununs.
Yeah.
But that is an impedance matching transformer, which is different than a common mode current choke. So the device that I'm selling, the common mode current choke test rig, is not useful for matching transformers.
Yes.
Because transformers are working on differential mode currents.
Yes.
So you don't need my device to measure the effectiveness of a 4-to-1 transformer. What you need is a load that is 4 times your system load. So assuming a 50 ohm system, you need a 200 ohm resistor on the 4 side of your 4-to-1 transformer. And then you can hook that up to port 1 on a VNA, and it will measure the reflected signal coming back, and it should be, 0, or you should have a lot of insertion. It'll be called return loss.
Right.
What you want to measure is the return loss. As long as it's 15, 20 dB or more, then it'll probably be a good transformer.
Yes.
Jody brought up VE5 SAR, brought up a company called Rugged Radios that makes a number of headsets and intercom type units. That is true. Rugged Radios kind of fits. There are some things about Rugged Radios that hams may or may not like. We're not going to go into any.
We're not going to go into that.
But I will say that Rugged Radio fills a niche, quite a nice niche, because their stuff is more expensive than what you can buy on AliExpress, and more expensive than what you can, like a inexpensive PC gaming headset that you would buy off of Amazon, but less expensive than a Heil,
yeah,
and less expensive than a Radio Sport or a Dave Clark, right? Like, so those kind of define one end of the price quality spectrum for headsets. And like $50 off of AliExpress or $40 off of Amazon for a inexpensive PC gaming headset is kind of the other end of the spectrum. Rugged Radios is kind of in that middle, about $200 for a pretty nice headset. I will say that they are decent headsets. Rugged Radios is 2 blocks that way from me. They are a local company to me. They literally built a new building down the street from my house.
Wow.
It, like 2 years ago, it was a field, like with an agricultural field. And they bought this corner lot and built up a brand new facility for themselves. They've got all kinds of garages where they show off their neat cars and stuff. And they got a big showroom and, the warehouse there with all their stuff. And Rugged Radios is literally right there, which is kind of neat in my opinion. I have been known to walk down the street to go buy some parts from them. I needed some 6-pin mini XLRs and they had them in stock. So I walked down the street and bought some.
There is no, what I'm trying to say, whenever you buy headsets and you buy, if you're going to be a big DXer and you're going to sit in front of your radio, or you're going to be a contester and you're going to spend hours and hours in front of your radio, having a good headset is key. You would not believe, like us right here, this headset is great, but if I have this on my head for more than 3 or 4 hours, it starts to pinch my ears and it's not comfortable.
Are those AKGs?
What are these? These are, they're AKGs.
Okay.
Yeah, 240s, K240s.
You'll notice the other part of my website said audiophile hardware. I haven't gotten into any of those kits yet, but I intend to start selling headphone amplifiers as well.
Yeah.
I'm an audiophile.
So having good headphones is one thing. If I could, whenever I'm getting better at CW, I have a pair of in-ears that have been molded to my ears.
Oh,
and
nice.
Those will be my CW headphones. But since I do mostly single sideband, the Heils and the Radio Sport ones are the ones to get, because you can they fit good. They have a good seal. They don't after 12 hours of contesting, that you don't feel like they're rubbing the tops of your ears, and your ears are getting worn. So it's like, also in contesting, it's like getting a good chair. Like you have to have a good chair if you're going to sit in that position for so long. You got to have good stuff. But anyway, but I have not tried any of those rugged radio headsets, so I'm not really sure if they would be a good fit for, hours and hours. You would think that they would probably be decent because you're bouncing around in those buggies, right? And they have to hit, conform to your ear to, keep the everything out and everything in that is supposed to be out, and everything in that's supposed to be in. But I don't know. And I
do not own a set myself, but it's on my list to invest in at some point. I bought a set of Pro 7s, Heil Pro 7s, and Radio Sport, whatever the common one they sell is, for testing of the OHIS stuff, and some CTIA, PC gaming style headsets.
Yeah. I use Jason, so Smitty, what do you use, the Pro 7s?
I have Pro 7s and I have Radio Sport. Honestly, I like the feel of the Radio Sports a little better, so they are what I use more often when I go to a set of headphones or headset for radio stuff.
Yeah. I let's see if we can share
that's purely subjective, right? I don't believe one is better than the other. Actually, that's not true. I do have opinions. The Radio Sport separates their microphone ground return in the shield, whereas Heil does not. Heil combines them, and that's wrong. But that's anyway. Yeah.
Yeah. Well, I have the Pro Set Elite here. That mine does not look like this. I think I've got an older set, but this is what I use. And then Smitty, you said that you've got a Pro 7 here.
Pro 7, yeah.
Yeah.
Yeah, those are the ones that look like Dave Clark's or the aviation headsets.
Yeah, yeah. I tried some of these on at Hamvention and just didn't like them, but I did like these. And then we've got another manufacturer, Radio Sport, and they
Arlen, yeah.
Yep, and they look like this, and they're very comfortable. Like the Heils, and I mean anyone that you're going to get, they're very comfortable. Especially, I like the Radio Sports. They are very. They've got this cloth, squishy material that conform to your head, and the only thing that I didn't like about the Radio Sport is they're over the ear, which is great, but that squishy stuff it got unsquishy. And it wouldn't conform to my head anymore, and I had these gaps, right? And the one thing that, if you're a musician, the one thing that you don't want is, if you have in your monitors, is gaps and air getting in there, because it dampens the sound. And this is exactly what my Radio Sports did, so I switched to the Heils. But anyway,
so true story. Dave. Blanking on his last name. The guy who runs Arlen Communications Radio Sport, he also used to live in town. I didn't know this until after he moved out of town, but we lived just a few blocks from each other for about 20 years.
Oh, wow.
Yeah. Huh. And then I started working on this OHIS stuff and contacted him, and he's like, "You're in Arroyo Grande?" I'm like, "Yeah." He's like, "I lived there for a whole bunch of years." And wow, okay.
I think the bottom line is go to, if you can get to a big ham fest with these manufacturers, go and try them on, right? Yeah. And but if you have to buy a headset and you want it for POTA or contest or whatnot, any Heil and Radio Sport are the two ones that aren't going to steer you wrong. You're going to get plenty of cues in the books with those headsets.
They can be expensive. The opposite end of that spectrum, I have also had very good luck with. Like, go to Amazon.com and type in PC gaming headset and look for something that's $40. It's going to have that, single 3.5 millimeter TRRS connector, that 4-pin connector that you're going to have to adapt to whatever radio has. See above about Open Headset Interconnect Standard. Golly, wouldn't it be nice if there were adapters for that sort of thing? but you're going to have to do that probably for your Radio Sport or Heil as well.
Yeah.
Although the difference being that Radio Sport and Heil both sell the adapters that you need from their headsets to the various different radios.
Right. All right, very good. So let me put your website in the chat here a couple more times. So what else do you have, real quick, what else do you have coming down the pipe, Smitty?
Yeah, Jody corrected me. Dave Bottom is correct. That was the guy's name. So the only other product that I am actively working on right now, on the Ham Radio Workbench recently, we had Ben Quo, I think is how you pronounce his last name, AI6YR. We had him on, and he told us about his SatNogs setup at home, which is a satellite receiving system that you can set up just using like an SDR dongle and a hemispherical antenna, kind of like an egg beater.
Yep.
Egg beater. And it got me thinking, and I'm like, man, I'd kind of like to put one of those up. And I was thinking about the egg beater, and I'm like, well, I need a low, an LNA up there, low noise amplifier, and I kind of want it all integrated, and I don't want to just buy. Okay, anyway, like a weekend later, and I had a circuit board designed with an LNA on it and a common mode current choke and spots to solder the phasing loops for the cables on so that you could feed the aerial loops out of phase. And anyway, I've got it.
And you can use that for 2 meter and 440?
You can. The board is agnostic. So the board looks like this.
Okay.
This is an earlier version of it right here, but it's not focusing. Come on.
Focus.
Anyway, at the bottom is you solder a link of RG316, actually 2 of them. This is an earlier design, like I said, but you have 2 loops of RG213 that are the phasing loops, and then you got a little SMA port for a feed line, and then on top are the components for an LNA and a common mode current choke in the middle of it, and then these here attached to one of your aerial loops, and then these attached to the other aerial loop, right?
Yeah.
And the idea being that you would take this circuit board and slide it into the inside of a 1.5-inch piece of PVC pipe,
right?
Into a cap, and then this, the pipe itself would be the mast, and then I have a CNC mill that I wrote the program for to mill out the holes that line up with those holes for stainless steel hardware to stick through, and then it also like flattens out the little spot on because the cap is curved, right?
Right.
So I've been working on the G code for that, and that little circuit board that just kind of fits in here, and all of this will be a kit. So it's just the milled cap, the circuit board, the section of 316 that is long enough that you can cut it for either 2 meter or 440. But honestly, this board will work for just about any band. And then you are responsible for providing the aerial loop material, the mast, the ground plane, and the feed line, and everything else on the system.
Right. I mean, it's small enough that you could literally put that together, throw it in your car, and go and do satellite work portable.
So the 440 antenna is small enough to do that. The 2 meter antenna ends up being pretty darn large.
But I mean, it's not like it's a beam, right? I mean, it's probably what it's. Well,
it's 2 meters. A full loop at 2 meters is going to be 1/3 of, so about 60 or 70 centimeters long. Like the loop will be a diameter of about 60 or 70 centimeters.
Now, how about this? Could you? I don't know if this would remove the properties of the loop, but somehow up at the top you'd have a quick disconnect, and you could just unloop the sections, and then whenever you got to that location, you could connect the sections up at the top by maybe another circuit board and just connect them all together, and then you could have it totally portable.
Well, let me get this one working first. So this was a weekend project that I threw together, and I'm like, I do not have time for this. But when I started talking about it on our Discord channel, the Ham Radio Workbench has a Discord, and when I started talking about it, I got a lot of "shut up and take my money" memes, right? And so I'm like, okay, people want this. I found a few people who are able and willing to do the testing for me. So I don't have a convenient place to put up an egg beater right now. I've got a shop that's being built in my backyard, and I know exactly where it's going to go on the shop, but it's taking a hell of a lot longer than I wanted it to, and I don't have a place to put it up right now. So I can't really test these, but I just sent out 2 kits to each of 3 people for different designs of the circuit boards to kind of evaluate them and make sure that they work and everything else. So hopefully we'll be getting that back soon, and I'll be able to start selling these kits.
I mean, that would be awesome, because I know that the egg beater kits that DX Engineering sells from, I think, M5 or M3. M2, yeah. Those things, I'm thinking of Mythbusters. It's the $350.
And now, to be fair, that's all the parts, and that thing is indestructible.
Yeah, that's true. I mean, yeah, I will give them that.
Yeah, so this is literally just going to be these, the parts that you can't, that are not easy for you to make on your own.
Right.
Right.
But if you want to get into satellites and you want to, if you want to experiment, case in point, me. I'm getting into satellites, right? And that would be a great project for me to accomplish and put that up in my backyard, so I'm not sitting around there like this trying to figure out where the damn satellite is.
Yeah.
Whenever it's supposed to be there, but I got my antenna pointed over here,
Yeah, that's one of the reasons I wanted, so that I don't have to worry about pointing antennas and whatnot.
Right. Well, that's awesome. I mean, shut up and take my money.
Yeah, exactly. So James asked, he said, I could not find the OHIS mixer or the eggnogs. Neither of those are on the webpage yet, because they're still products in development. The only reason that the OHIS adapters are on the webpage is because I needed a way to sell them to my beta users. So those are up on the webpage, but they're out of stock, i.e. not available yet. Once the eggnogs design is finalized and I start selling those as kits, they'll definitely go up on the webpage. I'll probably put the webpage up earlier than that. Same with the contesting console. The contesting console is still in product development. The good news is that it's a very simple device, and I've done it before, so this should be a relatively short development process, unlike the OHIS adapters, which have a lot of complexity built into them. And I really wanted to make sure that those were right. But the contesting consoles and the egg beaters should be up in the next few months, I'm hoping.
Yeah. Very good. Anything else you're working on you want to...
No, that pretty much nails it down. Joseph brings up a very good point, though. VE3 GKT, why don't you bring up his comment on the screen?
Over time, sounds like Mark is the common denominator with the Workbench.
Yeah. Guilty as charged.
You know what? It doesn't matter.
So Jody asked the limits on the LNA. The LNA itself is good for, I think, 50 megahertz to 3 gigahertz, but I'm pretty sure the board is not going to be good up to 3 gigahertz. I mean, just like the lengths of these traces involved on here are longer than that. So no, I haven't measured it. My main target is 2 meter and 440. You could probably do 1.2 out of it. Maybe. I really don't know, though.
Yeah. And Don brings up a good point. Yeah. It's $350 each for the 2 meter and the, Yeah,
that's true.
Yeah.
I don't have a price for these. I think I know what it's going to cost me to make these. These kits will be well less than $100.
Yeah.
But I don't know how much less than $100 yet.
That's awesome. That's absolutely awesome to be able to get somebody into satellite work and whatnot at a cheap level, and your kit will be the gateway drug.
ADSB. Oh, that's a good point, Jody. I did not even think about ADSB. This would make a good ADSB antenna.
Oh yeah,
actually, that would, because it doesn't have the null of a vertical that directly overhead.
Yeah.
Oh, okay. You're now making me want to make sure that it will be good at 1090. Okay, I'll think about that.
See, you come on the stream and you get more work.
I know, right?
We're putting you to work there, Mark.
I know. Yep. We are way over. And yes, it is me. That's getting me to shut up is the hard part. I've said that over and over time.
Hey, I like when you talk. I learn a bunch of crap whenever you say stuff. So you're all right in my book. All right. Very good. Anything you want to promote? That's
that I haven't already promoted for the last hour and a half.
Workbench, right? Every other Friday,
Workbench, right? Every fortnight on Tuesday. We just dropped one this past Tuesday. We are going to be recording our post field day episode next Wednesday, but I don't know when that's going to drop. hamradioworkbench.com. Give it a listen. I am at Smitty at halibut.com on Mastodon. I have a Twitter account, but I don't use it.
Okay.
I'm also Smitty Halibut on YouTube, but I haven't been posting videos much lately. Once my shop gets built, it will be my office area in the shop will be built with a backdrop intended for YouTube streaming. So hopefully I'll be doing more of that before too long.
Very cool. Very cool. All right. Smitty Electronics, Smitty Halibut Electronics. No, Smitty Halibut. Hang on. Stop.
Take two.
Everyone stop. Just stop. Halibut Electronics on the web. Go
electronics.halibut.com.
The link is in the description below.
There we go.
Stop. Everyone stop. Stop. Quit putting things in words in my mouth. They're my words.
That's right. Smitty Halibut is my identity. Electronics.halibut.com is the company. All the links will be in the description below.
Yes. All right. Very good.
Thank you,
everyone.
Kyle.
We've said it all. We've said all the words. There's no more words to be said.
I could keep going. Challenge accepted.
Right.
No, we're good.
Well, we'll have you back on whenever we'll talk about more open headphone standard, and maybe whenever you get your egg beater working, we'll come back on and talk about that. So
contesting console, definitely.
Yeah. Yep. So all right. Very good.
Cool.
Thanks, everyone. 73.
73s. Be good humans.